Okay, now we're going to use a graphing method to solve a system of two equations. Here we have what we call a special system. We'll see what happens. It's rather unique. We're using the graphing method, which means we need to first isolate the y variable within both equations. We need y equals mx plus b so we can graph our line by hand. We need its slope, and we also need the y-intercept, the b term. So, hold on. No, don't want to do that. Okay, now we're going to show about this for the first equation. I know I want to isolate y. Usually we leave y alone. But I decided to move the y variable because it was negative here. It's minus y. So I decided to actually add y to both sides. And what happens is y becomes positive. So I have negative 2 plus y. So I decided to approach it that way. Now we have negative 3x plus 2 equals y. Negative 3 is my slope. And the b term, the b value for the y-intercept y value would be positive 2. Now, as we can see here, our second equation is y equals negative 3x plus 2. The y variable is already isolated. I have no work to do for that equation with that equation. So we have minus 3 for our slope and positive 2 for our b term, for our y-intercept. Now what we notice here is that both slopes are the same and the y-intercepts are the same. So we have 0, 2 for the y-intercept and negative 3 for our slopes. What that means is both equations share all the same pairs. Let me show you on a graph what that looks like. Now we'll use my grid here, to graph both lines. And you should see both lines occupying the same space, meaning all the x and y pairs are shared by both lines. Okay, now you can see the red line here, and that the slope is -3, so it's going to go down from left to right. And the y-intercept is 0, comma 2, which is on the y-axis right there as we see. Now we're going to graph the second equation in blue, and it should be in the same place as the red line. And there you have it. We can see that we have the red line and the blue line are on top of each other, are occupying the same space. So all the x and y pairs that one line has, the other line has the same pairs. This is called a dependent system. If you were asked how many solutions for this system, you could say infinitely many, because each x and y pair works for both lines. See you next vlog. Thank you.